Today we're practicing factoring using special formulas. I began with the difference of two squares formula. The big thing I would highlight about all of our formulas is that if we can model the formula with our given equation, then we can easily find a solution. So where I have a difference of squares here and everything is about the A and B, I would want to highlight that I want to represent my new equation in terms of the A and B, one square before the minus one after. As I'm given the equation x squared minus 36, I can note that the x certainly models the A. In fact, I write parentheses here to emphasize the idea that my A in my formula is now x in this problem. However, 36 is not a perfect square. That I need to rewrite. As we know, that is a perfect square of 6. And so from my formula, now behind the minus, what I have represented as the square, which is the B, is 6, not 36. Therefore, I have a difference of two squares, A and B, or in this case, x and 6, and therefore the solution will be the sum and difference of the x and 6. The biggest error that's seen with these is people taking the 36 instead of 6 and substituting into the formula. So I say again, model the variable that is in the formula with your problem and you won't have that error. For my second example of the difference of squares formula, I now add in more than just one in the factors in both the initial and the second term. And so this time as we go to write each of these as perfect squares to model the formula, know with me that the 4x squared is a perfect square like A of 2 and x. Using the power rule we can group and therefore identify our A. Everything before the minus that is squared will be my A, and that is 2x. As far as my second term, B, what will be squared, or the perfect square of 16, would have to be 4. And so therefore I have a difference of two perfect squares of A, 2x, and B, 4. Hence, my solution, the product of the sum and difference of A and B, which we've already noted, 2x and 4 respectively. This time we're practicing factoring special formulas with the sum or difference of two cubes. I begin with the sum of two cubes formula. And note again, as we talked about with the difference of squares, before the plus sign is my perfect A. You'll note with me already that x is what I'm going to consider to be my A, my perfect cube. Unlike the first term, I need now B cubed, and that is not 27. However, 27 is a perfect cube of 3. And so I can now say from my formula that I have my AX and my B respectively 3. Easy substitution into my factored formula. So that's A plus B times A squared minus A times B, that's X times 3, plus B squared, that would be 3 squared. Of course, we have some simplifying to do here. And so that's x squared minus 3x plus 9. The biggest thing I want to mention about the sum or difference of cubes formula is that the trinomial in that formula is not factorable. Where we normally would see a perfect square here and consider factoring, it's wise to note that this trinomial with numbers or without is not going to be factorable over the set of real numbers. So we know that we have this factored as much as possible, x cubed plus 27. So we're factoring by the difference of two cubes this time. And note that our 8x cubed is to represent our initial term, and so recognizing that we need an entire cube, 8, perfect cube of 2, and of course x cubed, the perfect cube of x. Where we can now recognize that our A in our formula is the grouped cube, 2x, not 8x cubed. And for B, same story. We have a B that will be a perfect cube of 5. And so B must be 5, not 125. And so as A and B are 2x and 5 respectively, we can plug into our formula A minus B, the A squared, plus A times B, plus B squared. Simplifying here, we have 2x minus 5 times 4x squared. I often get 2x squared here. Both should be grouped and therefore written. Plus 2x times 5 plus 5 squared. I remind you again, this trinomial, which looks to be factorable, will not be factorable over the set of real numbers. And so we know that we have this completely factored.